So much like maths, anything in blue is examples and stuff that I believe that you should write. Anything in black is just for me to help deliver it to you. So towards the end of last lesson, you got a term called stoichiometry, but this is hard yards. We're not kidding around that it's year 11 stuff, so the energy was a little low. I want to go over some of the terms again so that you get it fresh, because we're leading into stuff that's quite difficult. So what is stoichiometry? Stoichiometry is the branch of chemistry that looks at the relationship between reactants and products in a reaction to determine the amounts that are involved in those reactions. This is a difficult concept to grasp in chemistry because we're aware that substances are made up of atoms. Atoms are really friggin' small. So there are very many atoms even in small amounts of substances. When I did chem at high school, I was one of those kids that was just good at using the formula. I did that in spec as well. I didn't get it. I was just good at answering questions. But because I'm older now, I want to understand it. And if I feel like I understand it, I might be able to give that understanding to you. Okay? So I'm going to try to deliver this to you in a way that I use to understand it. I'm going to use some metaphors here. When I say a dozen, what the hell do I mean? 12 things. So if I have 5 dozens, how many things do I have? 60. Good. That would have taken 5 minutes for the mainstream class to tell me 60, but whatever. A mole in chemistry is a standard scientific unit for a very large quantity of very small things. What is a dozen? It tells you a quantity of 12. So a mole, I'm trying to say that they're similar concepts. A dozen is similar to a mole. We measure the number of particles in chemistry in terms of moles. A mole is friggin' this. Is it helpful to remember that, like maybe year 12 or not really? It's not that, you don't need to memorize it, but I want to give you an idea of how big we're talking. A mole is 6.02214076 times 10 to the 23 particles in scientific notation. In full, what is that? That's that many particles. This is also known as Avogadro's number after the physicist who came up with the idea. So you can see that the idea, you should say I'll fix that after, of the term moles is directly in relation to the amount of something. Is that clear now? Okay. Instead of dozen, we're saying mole, and a mole is friggin' this number here. So, we did this. These are the 3 stoichiometry formulae. There's 3 important formulae used in stoichiometry. The first one is the number of moles formula. Don't worry about writing this because we'll go over them specifically one by one. The number of moles formula, the concentration formula, and the last one we finished on was the dilution formula. So let's have a closer look at the number of moles formula. This is where you should start getting stuff down. The number of moles formula is the number of moles N equal to the mass in grams, small m, divided by the molar mass, big M. You practiced using those, but it's nice to take a step back and just refresh to have like a little overview and see how it all fits together, yeah? And if I wanted to go in words about what this formula is about, it tells me the number of moles I have of a substance. As long as I know the mass of the substance that I have in grams, and also the mass of a single mole of that substance, the molar mass. Can someone remind me what you did last week to work out the molar mass of a chemical? You did it for sodium chloride. What did you look at? Where did you look for that? Where? Underneath the periodic table. So someone in the past decided that what's important on the periodic table, how many protons there are in the nucleus, because that decides what element it is. And those numbers underneath on the periodic table, that tells you how heavy in grams 1 mole of that particular element is. And what is a mole? 6 bajillion, trillion, whatever. That many particles of that substance. So can you get number of moles formula down, please? So like I said prior, I was just good at answering questions. I saw this formula, I looked at the question, I just tried to fill in the formula as best I could. But I'm getting a feeling now, going over it and learning about how kids learn, that you can do it with metaphors. So I'm going to hit that metaphor again. You can think of it like, how many dozens do I have if I have 500 eggs? But I need to do some conditions here. If I directly replace the term moles with dozens, and I assume eggs were 1 gram each, what would this maths look like? If I've had 500 eggs, what would the mass of that be if I assume each egg is 1 gram? What would the mass of eggs be? 500. Over. What is the mass of a dozen eggs? If I'm assuming 12. Can someone get a calculator? It's 500 divided by 12. It's a number. Of course it's a number. I'll do it on my... So I know it might be painful.
It's 41.6666.
Yep. 41.67 to 2 decimal point dozens. Now it's probably painful for Miss P for me to hammer this metaphor. But the point of it is to give you an idea of what a mole is. A mole is telling you the number of many things. And something that you all can access is the idea of a dozen, because you know a dozen is 12. So if I know how heavy my substance that I'm interested in, and I know how heavy 1 unit of that thing that I'm trying to count is, then I can work out how many moles is in my collection of substance, all right? That's how that formula works. So let's do it for a real example. Can you get your little periodic tables out so you can help me out? I don't remember it off the top of my head.
I'll go get the rest of them for those of you who...
Let's pretend I have 50 grams of sodium chloride. I have 50 grams of salt. How many moles are we talking about here? So N, the number of moles, is equal to the mass of the substance divided by the molar mass of it. How many grams of salt do I have in this example? 50 divided by. You need to help me out. I don't remember off the top of my head how heavy sodium chloride is. But how heavy is 1 mole of sodium? Sorry? 22.99. But that's not all that's in sodium chloride, because chlorine's in there too. What is chlorine? 35.45. So I'm dividing the mass of 50 grams of this salt stuff by how heavy 1 mole of the stuff is meant to weigh. So it's going to be 22.99 plus 35.45. So it's 50 grams of salt divided by 58.44 grams is what 1 mole of sodium chloride should be. If I've got 50 grams of sodium chloride, do I actually have a full mole of it? No, I have less. So when I divide a smaller number by a larger number, do I get a fraction? Does that make sense that I would have a fraction? Because I don't have 58.44 grams of sodium chloride, which is what 1 mole is supposed to be. It's going to be 50 grams. I've only got 0.86 moles rounded to 2 decimal points. Any cringes yet? It's all good so far? Thank you. Can I get that down, please? Upcoming on the notes is pictures. Don't worry about copying the pictures because I'm going to demonstrate them with these bottles here. And this video will be up on YouTube if you need it in future. Is that nice to go back and just review with these metaphors what that formula is about? Huh? Concentration formula, let's have a look. So you had this as well. Get that formula down. You don't get cheat sheets, unfortunately. The concentration of something... Oh, I wasn't meant to write. That was supposed to be a laser pointer. The concentration of something is the number of moles divided by the volume that it's mixed into. What does this give you? This formula gives you the concentration of a solution in moles per litre. As long as I know, and let's chuck some terminology at you, the number of moles of solute, so you can think of solute as the stuff that I put into liquid, and the number of litres of solvent. Solvent is the main part of a solution, it's the liquid part of the solution. And just FYI, for your information, a solution is a mixture of one or more solutes that are dissolved in a solvent. Can you please get up to the end of this little section here so that you have that for your record? Lucky for us, I don't need pretty metaphors for this little bit. Could you give me some paper towel, please, and then bring it to the front? Nowhere. No. All right, let me demo. Hopefully you can see this table. Huh? Thank you. It's just in case. Thank you very much. Yeah, you take it. So there's your formula. Let's demonstrate how this works with some easy things to start off with. Please consider these jugs at the front, they're all 2 litre jugs. This is halfway full. So how many litres do I have in this one? 1 litre. I'm going to put 5 drops in it. And the only imagination that you need to do is 1 drop. We're pretending is 1 mole. We cool with that? So I'm going to put 5 drops into this. 1, 2, 3, 4, 5. So if we're pretending that 1 drop is 1 mole, what's the concentration of this? How many moles per litre? 5. Why have I chosen 1 litre? Because it's just divided by 1. Let's demonstrate that here. Concentration is the number of moles. We put 5 moles of blue into the water divided by the volume of 1. So it's 5 moles per litre concentration. Okay? But what if I did this? So this is 1 litre. This one is half of that, so how many litres do I have here? 0.5, 500 mils, 0.5. I'm going to put 5 moles in there again, 5 drops. 1, 2, 3, 4, 5. I put 5 moles in there, so surely the concentration of this is 5 moles per litre, is it not? No, why not? Because it's half, okay? So what would happen to the concentration? Would it be half or would it be double? Double. And you can confirm that with the maths. So it's going to be 5 divided by 0. What? Is it still going to be 1? It's going to be 0.5. 5 divided by a half is going to be 10 moles per litre, -1. Does this result make sense? Does it make sense that if I put the same number of moles in half as much liquid, it's going to be double the concentration? Good. When I was going through this in high school, I literally always thought of cordial. If you want to think of Milo, that's cool. But whatever it takes to understand something, do it. Okay? Please note, this is one that I need to check with Miss P. The concentration 1 mole per litre, I believe you refer to that as 1 molar or 1 capital M in Year 11 and Year 12. You're going to see this often. So if anything, the only things to get down would be this note here. Concentration of 1 mole per litre is also referred to as 1 molar or 1 M. This demonstration that I've shown at the front is summarized in these pictures that you can see later if needed. It'll be attached to this lesson on YouTube. A couple of moments to get this down, please. 1 mole per litre is 1 molar. So that's 2 down out of 3. Let's hit the dilution formula because we want you to practice hitting this up today. So what is the dilution formula? The initial concentration of a solution times by its initial volume is equal to the final concentration of the solution times by its final volume. Why is this useful? It shows that there is a direct relationship between the concentration and volume of the starting solution and the concentration and volume of the final solution if I change the volume by adding a solvent. You're not adding the blue stuff. We're talking about adding the clear, the water, okay? So if you can consider that situation on the board right now. Got 1 litre of water here. All right, please consider, I already did this just previously. How many moles of blue did I add to this 1 litre before? 5. So what would the concentration of this jug be? 5 moles per litre. If I added solvent to this, if I added water to this to make it up to 2 litres, what's going to happen to the concentration? Be less or be more? Less, because am I changing the number of moles of stuff in this at all? I'm not touching that. I'm touching the amount of solvent that makes it up. Do you notice that it's more see-through? Is it less concentrated? I don't know you probably know because you're ignites, you know what the concentration is already, but you have a formula for this. Use the formula. What is the initial concentration? What was it before I added the water? It was 5 times by. What was the initial volume? It was 1 equals C2. I don't know, so I leave it unknown. Times by. What volume is it now? 2. Do the math. I teach you for maths. 5 times 1 is 5 equals C2 times by 2. How do I get rid of multiplying something by 2? Divide both sides by 2. Divide by 2, divide by 2. That cancels out. So you're going to get C2 is equal to 5 over 2, which is 2.5 moles per litre. Does that result make sense? I had something that was concentrated 5. I doubled the volume of it without adding stuff into it, just liquid. It should be half of the concentration. But let's do a further example here. Try to make it a little more... Obviously, your numbers are not going to be so nice. But if you can do it with nice numbers, you should be able to do it with dodgy ones, because the formula is the same. So what I used to have concentration of 5 moles per liter, right? I'm going to put half a liter of this. No, wait. No, that's what this was prepared for. This is half a liter, right? And I've transferred, this was transferred from the previous one, which is 5 moles per liter. It used to be 5 moles per liter. I got half of it, and I put it in here. Is the concentration any different? No, I've just got half of what it was. So the concentration is still 5 moles per liter. If I added solvent to this, to make it up to 2, so this is 1.5 here. So a slightly more complicated example. I made it slightly more complicated and then I got confused. All right. What concentration is that going to be? Do we have a formula to work it out? Is it as easy to guess this one though? I see one nod, but is it as easy to, is it going to be 2.5? No. Why is that? It was 500 mils. It was half a liter of 5 moles per liter. So how many moles was in it? No. Its concentration was 5 moles a liter, but I only had half of a liter. How many moles was in it? Huh? 2.5. And then I made that up to 2 liters. So it is slightly more complicated, okay? Let's do the maths. Using the formula, the concentration it started off with was 2.5 moles per liter times by, no, sorry, it was 5. It was 5 times by half a liter equals, I don't know what the new concentration is, but what did I increase the volume to? 2? What's 5 times 0.5? 2.5 equals C2 times by 2. What's the opposite of timesing something by 2? Dividing by 2. So C2 is going to be 1.25. Does that result make sense? Probably should have practiced that more, but we got there in the end. Okay? What was the initial? There was 5 moles to start off with. But then I grabbed this and then I halved it. How many moles are in this now? 2.5. Did I change the number of moles when I went from second to third jug? Did I add any blue? I only added what? I only added water. So there's still 2.5 moles in there. And you're probably going, why is the concentration not 2.5 moles? Why isn't it going to be 2.5 moles? How much water is in there? 2 liters. All right? So that halves that concentration there. That was almost did that work out okay at the end? Yep. So what I'd like you to do is I'd like you to practice using these 3 formula for the rest of the lesson. I want to do the first one, which is on slide 67, to show you the thinking. This is how you need to be thinking, especially you guys in extension maths. You're moving away from, you must use this formula, you must use this formula, you must use this formula in order. That's not how it works at senior school. You're going to be given a toolbox of formula, and you need to work out which one you need. So, currently you have 3. You have the number of moles formula, you have the concentration, and you have the dilution formula here. I have a question. 10 grams of sodium hydroxide is added to 250 milliliters of water. What is the concentration of the solution? So in red is what I'm thinking. What is the thinking? I have a toolbox of 3 formula. I want concentration. So which one of those formula am I going to use? Second one. Could it involve this? Because concentration's in it. But does this question have does it talk about dilution at all? So it must be the second one here. I'm using that. Now, once you've decided the formula, what do I know? What do I know?
Well, you need to find how many moles, 10 grams of...
Yeah, you skipped over the story that I wanted, but he's right. What's the first thing I know, though, directly? What is the thing that I know from the question? The volume. What do I know? Volume is 250 mils. Try to work in litres. So what's that going to be in litres? Therefore, 0.25 litres. Then, what do I want to know?
How many moles, 10 grams?
I want to know the moles in 10 grams of sodium hydroxide. So do I need to use another formula to find that out? Which formula tells you the number of moles I have of something? The first one, N is equal to small m, which was the mass of the stuff. How many grams of the stuff do I have? 10. Do I currently know the molar mass of sodium hydroxide? Can you work on it for me? Someone over there, can you work out what H is? Someone over here, what is sodium?
I already...
22.99 plus. Someone else find oxygen for me? Sorry? 16 straight?
Yeah.
Oh, wow. What's hydrogen?
1.008.
Let's just make that 1.01. 10 over...
comes to... Rounding to 2 decimal points, it comes to 40. Which is pretty well 40, isn't it?
40,
3 decimal points is 39.99.
let's just go 40. And 10 divided by 4? 4? What is 22.99 plus 16 plus 1.0 going to be? 40? And then what's 10 divided by 40 going to be? 0 point? So how many moles of sodium hydroxide I have in 10 grams? Moles? Do I have what I need to fill in the concentration formula?
Yeah.
Concentration is going to be 0.25 moles. 0.25. What's the concentration going to be? 1 what?
Mole per liter.
And then to be nice, because we're in senior maths, what's the better terminology for 1 mole per litre? 1 molar, therefore 1 capital M.
So we can use moles per litre. Moles per litre is most commonly used, but they will need to know that N molar is used interchangeably. Moles per litre is still probably better to use the full unit for understanding.
All right, can you get that example down, please? After you've got that, can you go to slide 67 of the Advanced Chem presentation and practice using those formula? And then if you've done that, chuck your hand up because you've got a worksheet that you can work through.